What's going on, everybody? It's Mr. Gustin. I'm next to the physics classroom in my conference room doing some practice problems with electroscopes. We've discussed ways of charging, and we say that there are 4-ish ways of charging. There's 3 names, 4 types of charging. We've got charging by friction, we have charging by contact, we have charging by induction, but there's 2 types of induction. We have induction by polarization and induction by grounding. So there's 4 ways, but really 3 big names that we use for our ways of charging. 2 are related to contact, and 2 are related to induction, okay? But now that we have these different ways, we can also then model how these charges move and flow when something takes place, and if it's going to be charged or not, or if they're going to be attractive or neutral or positive or negative. We can track the movement of electrons. So we're going to do some practice problems now. Practice problems with electroscopes and ways of charging. We got 3 on the board. We'll do all 3 together. Practice along with me or just take notes. Ready? Here we go. First question. I got a positive rod brought near a neutral electroscope. The first thing I should do, I read this problem, I should draw myself a positive rod. Here's the positive rod brought near, net positive charge. It's brought near the electroscope. Now it tells me the electroscope is neutral, so originally this electroscope has both positive and negative charges in it in equal amounts. As I bring it nearby though, the negative charges that exist near the top are going to be pushed down towards the bottom. That's going to give me some negative charges down here in the leaves, or the things that sway away from each other. That will leave the the negative charges are not doing that. The negative charges will be attracted to the positive rod. That will put the negative charges up on the plate of the electroscope, and that will leave these leaves with a net positive charge down here. What will that do? That will take these leaves and actually cause them to spread out. They'll be repelled from each other, so we'll see these things kind of do one of these numbers, right? Positive charge, positive charge, positive charge. They're going to repel from each other, and then as I pull this thing away, they would go back. That's not what I'm asking you. I'm asking you what would happen if a positive rod comes in. Well, the electrons would flow up, leaving excess positive charge down below. This is what the electroscope would look like, and that's it. That's it. That's it. So if I ask you a multiple choice question, say, hey, pick a model of the electroscope if a positively charged rod is brought near the top. That's it. Game over. End of story. All right? Number 2. Also, side question. What kind of grounding is this? This is induction by polarization, right? It's not going to stay charged. There's no permanent charge on it, but this is inducing that pole on the electroscope. As I pull it away, that pole would disappear, but for now, that's induction through polarization. All right, question 2. Question 2, I've got an electroscope. It's charged by contact from the positive rod. Now, it doesn't say it, but let's go ahead and assume that electroscope is neutral to begin with, and then we touch a positive rod. So it tells me first thing I'm going to do, I'm going to draw a positive rod that is in contact with the top of my electroscope. That's the first thing we're going to do, okay? Now, it's neutral. Any negative charges that are in this electroscope aren't just going to be attracted to that positive rod. In fact, they're going to flow into the positive rod because we have contact. So if we start this electroscope looking like this, because it is neutral, we know that any of these negative charges are going to flow into that positive rod. What is that going to do? That's going to leave my electroscope with a net positive charge. And that rod will now be neutral. Right? I'm going to neutralize that rod or more neutral because I've left those things up there. So if I ask you, what does the electroscope look like after contact from the positive rod? Those electrons from the electroscope are dumping into that positive rod, so we're left with an overall positively charged electroscope in the end. Far fewer electrons exist in it than there were to begin with. All right, question 3. Also, charging by contact. That last example was charging by contact. Third example, a person touches a positively charged electroscope. So essentially, we're taking example number 2 and saying we're going to start there. So let's start with example number 2. And imagine instead of this neutral rod, now I take my hand and I touch the electroscope. What is going to happen when I touch it? So I'm going to go ahead and draw my hand. That's my hand, can't you tell, right there. When I touch the electroscope, I have got neutral charges in my body, right? I'm not a great conductor, but I do have both positive and negative charges. This electroscope will be seeking electrons or seeking those negative charges. So when I do touch my hand to it, because the two objects are going to equilibrate in charge, those negative charges, those electrons will begin to flow into my electroscope. They will dump into that positive space. And so because of that, what ends up happening is I end up neutralizing my electroscope. So what happens when I touch a positively charged electroscope? Well, the electrons from my hand from the ground dump into the electroscope and return that object to neutral. We call that charging by grounding. We are grounding that object when we touch it to something like our body or the floor or a wire or something like that. Okay? 3 examples on how we might use the ways of charging to track charges in the electroscope. If you've got questions, drop in the comments, send me an email, ask me in class, all right? Until next time, see ya.